Viewers, welcome to add-on. In this question, we are asked to describe the half header and a full header for a binary addition. So at first, let us learn about what is a half header. Okay. So the block diagram for a half header is, consider this is a block, and this block functions as a half header. Okay. This block function as a half header. Now the primary job of half header is to add two bits. 2 bits. By the addition of 2 bits, I am meaning that we will add 1 plus 1 or 0 plus 0 or 0 plus 1, which means that 2 bits are getting added, but it is only a 1 bit addition because only 1 bits are used for addition. But the total number of bits which is used for addition are 2, because in this case, if we see, this is a 1, so only 1 bit number is used on the one side of the addition, and it is added with another 1 bit number, so it performs 1 bit additions only. Okay, so the primary job of half adder will be to perform the 1 bit addition. Now to perform the 1 bit additions, we need to give inputs which are two 1 bits number. So let us say first input is A and second input is B. A is a 1 bit number which can be either 0 or 1, and B is a 1 bit number which can be either 0 or 1. Okay, so one thing we need to know, at the first I have mentioned it performs the addition of 2 bits, because this is a bit 1 and this is a bit 1, so total 2 bits are getting added. But the purpose of addition will be to add only 1 bit, to add the to perform the addition of 1 bits, because if we perform 1 plus 1, it will give us a 1 bit addition, but if we perform 0 0 plus 0 0 or 1 1 plus 1 1, it will be a addition of 2 bits. Okay, so it perform addition of total of 2 bits, but it is individually a 1 bit addition. Okay, so I think I have made my point clear. So we are giving the inputs to the half adder as A and B. A is a 1 bit number and B is a 1 bit number which can assume the value of 0 or 1, and B can assume the value of 0 or 1. Now the outputs are, one output will be sum which we are represented by S, and other output will be C out which represent the carry. Now the rules of the binary addition, as we know, are, if we are considering 2 bits 0 plus 0, we will get 0 as sum and 0 as carry. And now if we add 0 plus 1, we will get 1 as sum and 0 as carry. And if similarly if we add 1 plus 0, we will get 1 as sum and 0 as carry. And if we add 1 plus 1, we will get 0 as sum and 1 as carry. Okay, so this binary addition we can represent it by the truth table to get our equivalent boolean expression. Okay, so the two inputs are A, B, and the outputs are sum and carry. So let us draw the truth table for it. So A, B, as I have said, they are both 1 bits number. So the combinations of A and B, they can be, A can be 0, B can be 0, A can be 0, B can be 1, A can be 1, B can be 0, or A can be 1 and, or B can be 1. And if we add A and B, now if we add 2 bits A and B, so 0 plus 0, it will give us 0 with a carry of 0, and 0 plus 1, it will give us 1 as sum and a carry of 0, and 1 plus 0, it will give us a sum of 1 and a carry of 0. Now 1 plus 1, it will give us a sum of 0 and a carry of 1. Okay, so we will write the boolean expression for the sum and we will write the boolean expression for carry. So as we can see, we are getting a sum of 1 for A is equal to 0 and B is equal to 1, and A is equal to 1 and B is equal to 0. So sum is equal to 1 when A is equal to 0, B is equal to 1, and A is equal to 1 and B is equal to 0. So we can represent sum as the value of A is 0. If the value of any boolean variable is 0, we will represent it by A bar, or if the value is 1, we will represent it by A only. So here in this case, we can represent sum as A bar B plus AB bar, because in this scenario the value of A is 0 and in this scenario the value of B is 0. So this is the expression of sum. And now for carry, carry is equal to 1 when both of A and B are 1. So carry will be AB. Okay, so this will be our carry. Now if we represent it by logic diagram, we can see how we are getting this sum and carry. So I have just erased the addition area to represent the logic gate diagram. So we can represent the logic gate diagram from sum and carry by this. So the two inputs are A and B. So we are just passing the two inputs through a inverter to get A bar, and B is passed through inverter to get B bar. Now the expression of sum is A bar B. So A bar is connected to a AND gate and B bar is connected to a AND gate. So it will give us A bar B. And now to get AB bar, we will just connect A to a AND gate and B bar to a AND gate. We will get AB bar. And now if we pass them to a OR gate, we will get A bar B plus AB bar, which is our sum output. Okay. And now for carry, we will just multiply A and B. So this is the B line. So this is the B. And what is the, where is the A line? So this is the A line, sorry, this is the A line and this is the B line. So we will just add them together to get AB. So this will be our expression of carry and this will be our expression of sum, and this is it for the half adder. Next our will be full adder. The next topic of discussion will be full adder. So similarly, like half adder, we are defining a block which is the full adder, and similarly at first we are giving two inputs A, which can be either 0 or 1, and similarly we are giving B, which can be either 0 or 1. And now alongside with A and B, we are giving another input, which is Cin. Now where does this Cin comes from? For example, let us consider the addition of 0 1 plus 0 1. Okay. Now as we know, 1 plus 1, it will give us a sum of 0 but a carry of 1. And in the addition of the next two bits, which is 0 plus 0, this carry will be added. So in this scenario, this carry, this 0 and this 0, these three bits are added, and if these three bits are added, we will get 1 0. Okay, so the purpose of half adder was to perform this summation, but if we want to perform this entire summation using half adder, we can't do this, because in half adder we are giving only the individual bits as input. We are not giving the carry which is generated from the addition of two bits as input. So the purpose of the full adder is to perform the complete addition process. Like in this scenario, we have added 1 plus 1. Suppose this is A, and this is B. So in this scenario, A plus B will give us 0 as sum but a carry of 1. But in this scenario, A is 0, B is 0. So if we just add A plus B, it will give us 0, which is not the required answer, because we need to add carry. So the other input will be the carry, which is seen in this scenario, which is the carry which is generated from the addition of the previous two bits. Okay. So I hope it is clear why we are giving Cin as input. And similarly, the output will be the same, S and C out. S is the sum and C out is the carry. So this Cin can either be 0 or 1, because here the carry is generated, so it is 1. But if the carry is not generated, it will be 0. So there will be no carry, right? So Cin can be also either 0 or 1. So let us write the truth table for the full adder. Okay. So A can be 0, B can be 0, Cin can be 0. We will just write the combinations for the 3 bits of A, B and Cin. So the combinations are 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. Okay. Now 0 0 0, if we add them together, we will get a sum of 0 and a carry out of 0. Now 0 plus 0 is 0 and 0 plus 1 will be 1. So it will give us a sum of 1 and a carry out of 0. Now 0 plus 1 is 1 and 1 plus 0 is 1. So it will give us a sum of 1 and a carry out of 0. Now 0 plus 1 is 1 and 1 plus 1 is 0 with a carry of 1. So it will give us a sum of 0 and a carry of 1. Now 1 plus 0 is 1 and 1 plus 0 will be 1. So it will give us a sum of 1 and a carry out of 0. Now in this case, 1 plus 0 is 1 and 1 plus 1 is 0 with a carry of 1. So it will give us 0 with a carry of 1. And similarly for this, 1 plus 1 is 0 with a carry of 1, and 1 plus 1 plus 1, it will give us sum of 1 and a carry out of 1. Okay, and now as we have done in the previous half adder case, we will see where we are getting s as 1. Okay, so we are getting s as 1 for 4 scenarios: when a is equal to 0, b is equal to 0, and c is equal to 1; when a is equal to 0, b is equal to 1, and c in as 0; a is equal to 1, b is equal to 0, and c in as 0; and a is equal to 1, b is equal to 1, c in as 1. So we can see a combination here. S is only becoming 1 when either one bit from A, B, or C is 1. So in the first case, C is 1, in the second case, B is 1, in the third case, A is 1, or all the 3 bits are 1, which is our last case. So S will be 1 for this. So if we write the Boolean expression for this, S will be equal to like A bar B bar C in plus A bar B C in bar plus A B bar C in bar plus ABC. So if we simplify this, it will give us just A XOR B XOR C. And now for the carry out portion, carry out is equal to 1 when B is 1, C is 1, and A is equal to 0. So carry out will be equal to A bar B C in plus it is 1 for the last 3 scenarios. So in this case, A is 1, B is 0, and C in is 1. So it will give us A B bar C in plus in this case A B C in bar plus ABC. The pattern we have observed in the sum that either one of the bits is 1 or all the bits are 1. And in this case, the pattern is quite the opposite, that either one of the bit is inverted, which is A bar, here in this case is B bar, here in this case is C bar, or all the bits are 1. Okay, so if we simplify this, okay, so if we simplify this, we will get C into A XOR B plus AB. Okay, so this is our expression of carry, and this is our expression of sum. Okay, so let us draw the logic gate diagram now. So we will draw the logic gate diagram now. So we have obtained the expression of sum as A XOR B XOR C, and the expression of carry as C into A XOR B plus AB. So to get the sum, we are giving 3 inputs A, B, and C. They are XOR gated together to get A XOR B XOR C. We can do it like this if it is a 3 input XOR gate, but XOR gates are normally 2 input. So let us write A, B. They are XOR gated individually to get A XOR B, and now C. They are XOR gated with A XOR B to get A XOR B XOR C. So this is our expression of sum. And now for carry, as we have seen, the A's or B is multiplied with C. So, or in other words, A's or B is AND gated with C. So this is the A's or B line. This is just AND gated with C, which is this. So here if we do this, we will get A's or B into C. And if we just AND get this two individual inputs, we will get AB. And now our final case will be just pass them through our OR gate. So we will get AB plus A's or B into C. Oh, and one thing we need to know, this C in this scenario is equivalent to C in. Okay, so this is our expression of sum, and this is our expression of carry, which is C out. Okay, thank you.